All right, welcome. In this video, we are going to look at some examples of molecules and see how we can use the Lewis dot structure to predict the shape of a molecule. So first step in figuring out the shape of a molecule is to figure out how the atoms are put together in the molecule. So we're going to draw the Lewis dot structure. So for this first example, we got CH4. So we're going to start with carbon. Carbon has four, it's in the fourth column, so it's going to have 4 valence electrons, so it's going to have 4 dots. And each spot where there's a dot by itself is a spot where a bond can form. And then each hydrogen has 1 dot, so each hydrogen can form 1 bond. So what happens, the hydrogens come in here, and they're going to bond with carbon at those 4 spots right there. So there's our CH4. And so when we're trying to predict the shape, there's 2 things we want to look at. We want to look at how many atoms are bonded to the central atom. So the central atom is the one that's in the center. So in this case, carbon is our central atom. And then we want to look at how many unbonded electrons are in the central atom. So in this first example, we've got 4 atoms bonded to the central atom, and there are no unbonded electrons. So notice how every electron has an atom on either side of it. That means they're involved in bonds, right? So these are all examples of bonds. There are no extra electrons hanging out that are not involved in a bond. So whenever you have an example like this, where there are 4 bonded atoms and no unbonded electron pairs, it is going to have the shape tetrahedral. So notice the shape name is already named for us off to the side. So any molecule with this example is going to be tetrahedral. And when you're in the class with the modeling kit, we can build it, and you want to sketch it in 3D. 3D sketch, you know, people have different I'm sure some of you have much better abilities at doing a 3D sketch, but sometimes what we do in chemistry is we make a little, you know, kind of shade and triangle to make it try and look like the atoms coming out away towards you, and then this one's going away from you outside the back of the table. So this is what that tetrahedral shape looks like. And remember, tetra means 4. Think about Tetris that has all those shapes in it that have 4 squares in them. So that's what tetra means, 4 things sticking out of them. And the bond angles, you don't need to memorize these. This is just, we're just kind of putting this out there so to give you a sense of what this shape looks like. It's about 109 degrees. So it's not 90, it's not 180, and it's somewhere in between. And since I can't show the, you know, the model kits right now in the video, I can go over and show you what this looks like in mol view. So this is what that tetrahedral shape looks like. So there you go. So that's tetrahedral. Now let's look at another example. Let's look at what a pyramidal molecule looks like. So we're going to start with nitrogen in the middle. Nitrogen has 1, 2, 3, 4, 5 electrons around it. So notice how nitrogen has 3 spots where it can bond. So I'm going to have 1, 2, 3 hydrogens come in. And now if I'm looking at this, notice that on my central atom, right, which in this case my central atom is the nitrogen, is the one in the middle, it has 3 things bonded to it. So we got 3 hydrogens bonded to it, and it has 1 unbonded pair. So that's what this is right here. That's a unbonded pair. Sometimes we call that a lone pair. It is not involved in a bond. Okay, so whenever you have 3 things attached, like 3 bonded atoms, and 1 unbonded pair, you're going to have a pyramidal shape. And we can build this, but let's just look this up right now in mol view. If we look this up, NH3, this is what that pyramidal shape looks like. The mol view doesn't show the electron pair, but the reason it has this shape is because there's some electrons up here that are kind of invisible, but they're kind of repelling these bonds, and that's why it makes it this shape right there. That's the one downside of mol view. It doesn't show those electron pairs. Okay, so it kind of looks like this. Basically what it is, it's like the bottom half of a tetrahedral. So up here, there's a pair of electrons. So if you were to look at the electrons, it actually would have a tetrahedral shape. But if you were just to look at the atoms, all we see is the bottom half of that tetrahedral, so it looks like a pyramid. So you see how it kind of looks like a pyramid here? You can imagine that visually. It's like a pyramid. Okay, there we go. So that's a pyramidal shape. The bond angles are still around 109 because it's the same basic geometry there as in the first example. Now let's look at bent. So water has oxygen has 1, 2, 3, 4, 5, 6 electrons. There's 2 spots for hydrogen to come in and bond. So this is what water ends up looking like. And notice that we have 2 atoms bonded to the oxygen. So the oxygen is our central atom. So there's 2 hydrogens bonded to it. And we also have 2 lone pairs. That's these over here. So this is why the Lewis dot structure is helpful, because it shows us both the bonds and the lone pairs. And wherever you have a bond or a lone pair, that's someplace where there are electrons. Electrons are negative. They repel each other. That's why these molecules end up having these shapes they do. Electrons are trying to get as far away from each other as possible. So what ends up happening here is, notice how we still have electrons on 4 sides. So we still are kind of following the same basic shape. So it's like there's some electrons here, there's some electrons here, and then you've got 2 hydrogens sticking off on 2 sides. So you're just looking at kind of one piece of this tetrahedral shape. It's like you're looking right here at this part of it. And we call this shape bent. And the bond angles are still 109. And here's what it looks like. Let's pull it up in MolView. In MolView, I can either search by the formula or the name. So this time I'm going to type in water. There we go. And you can see this is the shape of water. And again, MolView is not showing us the lone pairs, but the reason why it has this shape is because there's some electrons over here and over here that are repelling these bonds. Okay, there's some unseen electrons there that are affecting the shape. And that's what our Lewis dot structure shows us, those electrons. So we can see why it's going to be bent, because there's these negative electrons over here repelling them and causing them to bend away. So remember, these must stay as far away from each other as possible, because negative things repel each other. All right, let's look at an example of something that's linear. So carbon dioxide. So each carbon wants to form 4 bonds. Each oxygen wants to form 2 bonds. So what happens when you put them together, you end up getting this double bonded example. So let's write this a little neater. It looks like this. So we've got a carbon, and it's got oxygens on either side of it. So if you look at this example, your carbon has 2 atoms bonded to it, but there are no lone pairs on the central atom. There are some out here in the oxygens, but we don't really care about what's going on out there. We're just caring what happens to what about the atom in the middle? So that middle atom, the carbon, has 2 things attached to it and no lone pairs. And when that happens, the resulting shape is linear. So it's just a straight line. Because when you just have 2 things attached, the furthest apart they can be is 180 degrees. So that bond angle is just another way for us to help visualize what that shape means. Again, don't worry about memorizing what those bond angles are. It's just a way to help us kind of picture what's happening. All right, in this last one, here's what so I'm going through this quickly. Here's what our Lewis dot structure looks like. It looks like this. Okay, so in this example, when you look at your central atom, which is the carbon, the one in the middle, notice it has 3 atoms attached to it. There's no lone pairs on that central atom. So when we look at this, the furthest apart 3 things can be, looks like this. And we call this shape Trigonal Planar. And it's 120 degrees. So let's pull this up real quick. Trigonal Planar. CH2O. This is what trigonal planar looks like. So you see it kind of looks like a triangle if you look at the edges of the molecule. And if you go like this, you can see how it's all flat in one plane. So this is what trigonal planar looks like. Okay, it's flat in a plane. Versus, let's go back and look at that other example, NH3. This one, NH3, notice how this is pyramidal. This one, they are not in a plane. Remember, the reason why this one is not planar is because there's this lone pair up here of electrons. So with this example, with CH2O, there's 3 things attached and no lone pairs. It makes it trigonal planar. If you have 3 things attached and plus a lone pair, it makes it this pyramidal shape. So those lone pairs will affect the shape. So just want to keep an eye on both how many things are bonded and also how many lone pairs are on that central atom. Thanks for watching.